Hi, I'm Josh, an Alexa enthusiast. In this video, I'm going to show you how to get started with the Alexa Voice Service Device SDK from Amazon. This easy-to-use C++-based SDK helps you voice enable for your commercial device quickly and get to market faster with Amazon Alexa. So I'm going to do a demo really quick. First, I'm going to start the SDK. Alexa, are you ready?
I was born ready, or at least very well prepared. Let's do it.
Nice. Alexa, tell me a joke.
Why would Rafael Nadal make a terrible waiter? He takes too long to serve.
These jokes are terrible. My dad would love them. I built this demo in less than an hour using the sample app that is included with the AVS Device SDK from Amazon. Now that you've seen what this SDK can do, we're going to learn a little bit more about the SDK and also get started with a Raspberry Pi running Raspbian. But before we get into the first steps of getting started with the Raspberry Pi, I want to talk about the flow of information within the SDK so you understand how all the pieces fit together. So I'm going to start with a hands-free example. Let's just say, Alexa, are you ready? When you say Alexa, the audio signal processor takes your voice, digitizes it, cleans it up, and makes it easier to process later. At this point, it's sent to the Shared Data Stream, or SDS, where it takes the data and splits it to two places. The first place being the wake word engine, or WWE, and also the audio input processor, or AIP. When the data goes to the wake word engine, it's detecting wake words, or words that trigger it to listen for a command. In this case, the wake word is Alexa. The audio stream Alexa goes to the wake word engine, which then says, oh hey, Alexa's a wake word, and it triggers the audio input processor. The audio input processor handles audio input that is sent to AVS. These include on-device microphones, remote microphones, and other audio input sources. The audio input processor also includes the logic to switch between different audio input sources. Only one audio input source can be sent to AVS at a given time. Next, the audio stream that contains the sound Alexa in it is sent to the Alexa Communications Library, or ACL. The ACL is the portion that keeps a persistent connection between your product and the cloud to send and receive messages as necessary. Once the message is sent to the cloud, Alexa in the cloud processes the message and sends a message back, called directive, to instruct your product to take action. Now the ACL takes the directive that it just received from the cloud and passes it on to the Alexa Directive Sequencer Library, or ADSL. The ADSL takes directives that come in and enforces the ordering of execution of incoming directives and routes them to capability agents for handling. Once the directive that just came in from the cloud is slotted to go next, it passes that directive off to a capability agent. A capability agent handles Alexa-driven interactions and creates events. Each capability agent corresponds to a specific interface exposed by the AVS API. In this case, we'd want the speech synthesizer. So the ADSL passes speech file to speech synthesizer. Speech synthesizer then plays the speech file through audio player. Now, the Activity Focus Manager library is interesting because it changes the different activities from the foreground to the background. There are actually 3 different levels of priority. For example, dialogues are higher priority than content, such as music. Let's walk through an example. You're listening to music and a dialogue comes in. The ADSL sends the dialogue directive to the speech synthesizer. The speech synthesizer tells AFML that it wants the foreground channel. AFML tells the audio player to go to the background. The audio player ducks until it is informed that the speech synthesizer is done. When the speech synthesizer is done playing its audio, it informs AFML, which in turn notifies the audio player it can go back to the foreground. Alexa, what's the meaning of life?
The meaning of life depends on the life in question. 42 is a good approximation.
Nice hitchhiker reference. Now that we've seen how everything works together and how everything flows, we can get started with the Raspberry Pi and get it up and running with the SDK. I'm going to be giving a pretty high-level overview in this video. However, if you want more in-depth, step-by-step instructions and a better, more thorough tutorial, please go to the blog where we have a lot more information, screen captures, and everything. It's very easy to follow along. The first step that we're going to do is actually going to go to our computer and go to developer.amazon.com, where if you haven't registered for an account, you need to do so. On that website, we're going to register the device, we're going to input some device information, and then we're also going to copy some information in a notepad that we're going to need later to put into a JSON file. Now these 3 items are very important. They're the client ID, the client secret, and the device type ID. Now that we've got everything taken care of in the developer account, we need to actually get the device itself set up. We're running Raspbian on the Pi, and like any new installation, you need to make sure that it's up to date. Once you get the Pi up and running, you need to do the apt-get update and install and make sure all the packages are good to go. There are also some other packages you need to include that the SDK integrates with. A couple items, though, are items like GCC, making sure that it's up to date, as well as CMake and more. To get the SDK, clone or download the project from GitHub. For the purpose of this video, I will be creating a clone. As this Pi will be a dedicated AVS client, I like to put it on the desktop simply because then I can find it easily enough. Once you've cloned the project, create another directory, the build directory. Go into that build directory and do CMake to create a makefile based off of the information in the source directory. At this point, you can enable the wake word detector as well as indicate the library and include path to the detector. Once you've done CMake and it's created all of the requisite files in your build directory, you need to go in and find the Alexa client SDK config.json file. Insert that information that we copied to Notepad earlier, such as the client ID, client secret, and the device type ID. Make sure there aren't any extraneous characters and you don't swap them or anything like that, or you will have communication problems between your device, the cloud, and your account specifically, which means you won't be able to get your refresh token later. Once that's good to go, you need to go in and type in make, and then it'll take about 30 to 45 minutes. This is a great opportunity to go, eat lunch, or do something else that you need to. Now that the build is complete, we need to get a refresh token for the device. All we need to do is run auth server, which is a Python script that links through login with Amazon or LWA. You can find the auth server in the build directory and start a local server. When you run the server, if you run into any sort of errors, most likely caused by a mistype or mistake in copying info into the JSON file, make sure you click for more details. This will almost always give you exactly what you need to go look at and fix the problem. Once you get your refresh token, you're now ready to go and build the sample app. You also need to install the port audio and GStreamer to build the sample app on the Raspberry Pi. Before you run the sample app, it's important to note that the application takes two arguments. The first is required, and it is the path to the Alexa client SDK config.json. The second is only required if you're building the sample app with wake word support, and is the path of the folder containing the wake word engine models. Navigate to the sample app's source folder from your build directory, then run this command. Now that you've run that command, it's up and running, and now we can test this build. Alexa, what's the weather like in Seattle, Washington?
Right now in Seattle, it's 69 degrees with mostly sunny skies. Today's forecast has partly sunny weather, with a high of 81 degrees and a low of 59 degrees.
All right, perfect. So very quickly, we put it together and now we have a functional Alexa device. So today we learned about the architecture of the AVS Device SDK and how information flows from one library to another and how they all work together. We also got started with the Raspberry Pi by installing the SDK on Raspberry Pi and running the sample app. Again, for more information about the installation, please check out the blog where there's a more in-depth, step-by-step tutorial. It will be really helpful if you have any questions or concerns. As it is, thank you for joining me today, and I hope you enjoyed learning about the AVS Device SDK from Amazon.